Alright, so go ahead and get to our next lesson, 7.2a. In class today we talked about dilations and similarity and scale factor, and we're going to go a little bit further with that today. So investigating similar polygons. Similar polygons, well, polygons are any sided figure. 3-sided is a triangle, 4-sided, 5-sided, 7-sided, 10-sided, as long as the sides are straight lines. So we're going to do a whole unit on polygons later. But similar polygons are defined this way. So polygons are similar if and only if. So there's your magic words again. It has to be both things have to be true. Their corresponding angles must all be congruent, and the lengths of their corresponding sides must be in proportion. So that idea of scale factor, again, they must be proportional. So the angles have to be congruent, and the sides have to be proportional. So go ahead and pause and make sure you get that down, and we'll look at it. So pause now. Alright. So here's how we use it. This tells us right here, there's our symbol for similarity again. This tells us that ABCD is similar to WXYZ. So to find the scale factor of ABCD, which is the smaller shape, to WXYZ, which is the bigger shape, we divide the new figure by the old figure, basically. So WXYZ is similar to ABCD. We want to find the scale factor of this to this. So we just find two matching sides. You know, these look like the only ones that we know right now, 6 and 3. So from ABCD to WXYZ is 6 to 3, which is a scale factor of 2. And the other way around, the scale factor of WXYZ to ABCD. So going the other way, remember it's always the new figure divided by the old figure. So since we know they're similar, we know the corresponding sides are proportional. And this right here, that's a proportion. So 3 over 6 equals 1/2. So every side of the smaller triangle is half the size of the bigger triangle. That's similarity. So to find all our missing values, S, T, and U, I mean, we can do this without even doing much math. We know the scale factors 2 to 1 from the small to the big, or 1/2 from the big to the small. So if this side here is 7, this side here must be half that. This side here is 10. The corresponding side must be 5. This side here is 3.5. Again, corresponding sides are similar. They all follow that same scale factor. Alright, so S equals 3.5. T equals, where am I? T equals 7, sorry about that. And U equals 5. So scale factor. That's one way you can solve all of these problems. So let's see here. Find the scale factor of the larger pentagon to the smaller pentagon. So the scale factor of going from the larger to the smaller. So it's always the new figure divided by the old one. So the large one divided by the small one is 2.5 over 7. And I didn't have my calculator handy. Let's see if I can grab it real quick. There we go. Scale factor, 2.5 over 7. So, you know, about there. I'll keep it as a fraction. It's kind of nice to have it in that fraction form. So to find the value of the missing variable, we have kind of two ways to do this now. We can actually just multiply the scale factor by the side. Why aren't you writing? There we go. We can actually just multiply the scale factor. We're still not writing. Alright, let me pause here. Let me figure this out. Alright, here we go. So, we can either just multiply that scale factor by the side we want to kind of change. So we want to get that 20 down to the smaller pentagon there. So we can do our scale factor times that number, and that gets us to 7.14. The other way, that's a little easier in certain situations, is we can just set up a proportion. So we know that 7 is to 20. So 7 is to 20 as 2.5 is to y. So 7 is to 20 as 2.5 is to y. That's a proportion that matches up. So then we can cross multiply. We get 7y equals 50. Divide both sides by 7, and actually we get the same answer as above. Alright, so those proportions we set up, they can be set up in any way as long as it's a consistent relationship. So like another way I could have written this one is, let's say I say 7 is to 2.5. So 7 is to 2.5 as, and I want you to think for a second, what would have to go on the other side here? So 7 is to 2.5. So the big side over the small side equals the big base over the small base. So you'd get the same answers you would over here, just setting up in a different proportion. Okay? Example 3, let's set this one up. We won't necessarily solve it. But notice here's your two similar figures ABCD to PSRQ. And they're not really oriented the same way. They're turned a little bit, but the corresponding sides, you can still make them match up. So to find y, there's my y, there's a y. We have a couple different y's going on here. We're just going to set up another proportion. So let's say I do this. Let's say 5 is to 10. So if I say 5 is to 10, so this smaller top part over the smaller slanted segment there equals, now it has to match up with the other side of my proportion. 5 is to 10, and these have to match up as 3y minus 5 is to 4y. So notice how those proportions always match up. 5 is to 10 as 3y minus 5 is to 4y. Alright, so we cross multiply again. 20y equals 10, and careful here, make sure you distribute that 10 through. And I'll let you guys finish that one up on your own if you want. That's a solve you guys can do. Distribute the 10 and then solve for y. Now to solve for x, notice it's a little different. These are angles. And what we know about angles in these polygons, similar polygons, the angles are congruent. So there's no proportion to set up here. We're not going to say 4y is to 4x plus 27 as 10 is to 95. The angles aren't proportional. The angles are just simply congruent. So that's how you'd solve for x. Alright, the angles are just congruent. 4x plus 27 equals 95. Alright, so it's all about setting up those proportions. Okay, next page. Similar triangles. Alright, you have this note in your binder already, in your note packet. Two triangles are similar. All you need is that for their corresponding angles to be congruent. Their corresponding angles to be congruent. Alright, and then if two triangles are similar, just like before, it makes their corresponding sides proportional. Alright, so let's take a look here. First of all, how do we know these two triangles are similar? If you look, we have two angles here that are similar, and actually, we can prove, because the triangles have to add up to 180, if two of the angles are congruent, that means the third one has to be congruent. So that tells us they are similar, and I'll use my symbol here. They are similar because the angles are congruent. Alright, and the same thing here. We can do a scale factor, or you can set up a proportion to solve for x. I'm going to set up a couple different proportions just to show you again that there's several different ways to do it. So to find x, there's our key. I can say 24 is to x. So the left side of the big one over the bottom side of the big one equals, and on this side it has to be 9 to 15. 24 is to x as 9 is to 15. And then you cross multiply and solve for x, and we're done. Or, let's try another one. Let's say we do 15 is to x. So the smaller base over the bigger base. 15 is to x as, and if I do small triangle over big triangle, I have to do small over big on the other side. So if I use 12 here, notice I have to use 32 because those match up. So 15 over x equals 12 over 32. And we have many different options. If I say x is to 32, so x over 32 equals 15 over, x over 32, 15 over, it has to be the 12. That 9 is not part of it. So, same thing, and you can cross multiply and solve for x and you're done. Alright. Why don't we say, let's see, what else do I have going on here? Why don't we say these three will be your homework? Alright, so we're on page number 12. Example 2. Example 3. And example 4. Notice for this one, to get those triangles to correspond, where we talk about getting those sides to match up, see how this angle here corresponds with that angle there? These two triangles will match up through a rotation and then the dilation. So a rotation and then the dilation, to get the scale factor, the similarity thing. So this 4, think carefully about what side that corresponds with, okay? So questions 2, 3, and 4 will be homework, and then we'll get to here next time. Alright, questions 2, 3, and 4 are homework. Use your notes. I will put an online homework check for these. Alright, so you can put your answers in online. Alright, questions 2, 3, and 4 are homework. And good luck. See you next time.